we're given a piecewise function, and we want to see when it is continuous. Okay, so the first thing to notice is we're given 4 different functions. So always make sure that the functions by themselves are continuous. So ignore the domain restriction for now. So e to the x, we know that's continuous. X cubed plus 2x is a polynomial, which is continuous. 5x over x minus 2 is not continuous. So we know if we plug in x equals 2, there's a vertical asymptote. So here, x cannot be 2. And cosine of 3x is continuous. Okay, next, we want to make sure that the endpoints meet. In other words, they better have the same y value at the endpoints. So if we look at e to the x and x cubed plus 2x, the endpoint that they share in common is the -1. So at x equals -1, we want to make sure that e to the x is equal to x cubed plus 2x. So if I plug in -1, I have e to the -1 is equal to 1 plus 2. Well, that's not true. So because they don't meet at the endpoints, we know that it's not continuous at x equals -1. Okay, next we'll pair up x cubed plus 2x and 5x over x minus 2. So there they share the same endpoint as 0. So we'll look at x equals 0. We want x cubed plus 2x to equal 5x over x minus 2. Plugging in x equals 0, we have 0 equals 0. So yeah, that is true. So that means it is continuous at x equals 0. And then finally, we're looking at 5x over x minus 2 and cosine of 3x. There, we'll be comparing the 4 as the endpoint. So at x equals 4, we want to make sure that 5x over x minus 2 is equal to cosine of 3x. If I plug in 4, I get 20 over 2. And we want to see if that equals cosine of 12. Clearly, that's not true. So it's not going to be continuous at x equals 4. So the question is asking, where is it continuous? But my approach is going to be, where isn't it continuous? Because then we can look at everything that is not continuous. So the points are not continuous, we said are -1, 4, and 2. Okay. So these are the bad points, so we'll put a circle around there. So everywhere else, the function is continuous. So if you want an interval notation, that'll be from -infinity to -1, and then we'll put an open circle, because at -1 we said it's not continuous, and then from -1 to 2, open circle, and then finally 2 to 4, and then one more, 4 to infinity. Okay. So there are 3 points that are not continuous at that point, and thus we need to have 4 different intervals. So this is where our function is continuous. Okay, this next question is very interesting. So we want to see what are the horizontal asymptotes to the graph of f. So horizontal asymptotes is another fancy way of saying, well, what is the limit as x approaches positive and negative infinity? But you have to be careful here. The limit has to be finite, so it cannot be infinity, and it cannot isolate. So let's see. First, we'll take a look at x approaching positive infinity. So that would be cosine of x times e to the 2x minus 1 all over e to the 2x minus 1 plus 2. So the approach here is, in the long run, what is this function going to look like? Well, We know that cosine of x will always go between -1 and 1. So this is not a good notation, but this will kind of illustrate what's happening. So cosine goes between -1 and 1, and then we have e to the 2x. Then -1 really doesn't have an effect on our graph. It's so minor that we could just throw it out. And then we'll have e to the 2x minus 1 on the bottom, and then the 2, the same thing. It doesn't really do anything. So -1 comma 1 is where cosine is going. So again, this is horrible notation, and you shouldn't write this down, but I think it illustrates what's happening. Okay, so your coefficient of e to the 2x, think of it like that, is going between -1 and 1. And then e to the 2x over e to the 2x minus 1 is just e. Okay, so what does this mean? Well, in the long run, the maximum is going to be e, and the minimum is going to be -e. Right? If you multiply -1 with e, you get -1. I mean -e, and then if you multiply 1 with e, you get e. Right? So your y values will be like oscillating, back and forth between -e and e, which that is not an asymptote. So we have to throw this out. Okay. And that leads us to only checking x approaching -infinity. Okay, so this one is definitely tricky. So what we're going to do is multiply top and bottom by e. So you may be asking why. Why are you doing that? Well, the reason is because I have a -1 here. Ideally, I want to have e to the 2x over e to the 2x. I could have done the same thing to the other problem, but I guess it doesn't really matter. So this will be another approach. Pretend like I'm redoing the old problem, and I multiplied both top and bottom by e to the e. So it's just a different approach. Okay, so this, I'm going to have the e factored out for the numerator. And then the denominator, if I multiply e with e to the 2x minus 1, that becomes e to the 2x. Then I have plus 2e. Okay, now I want to take the limit as x approaches -infinity. Okay, so let's look at e to the 2x. E to the 2x is an exponential. So as x approaches -infinity, so if you're going down here, we're getting closer and closer to 0. So this thing is going to go to 0. And so will this. Okay, what does that leave us? Well, I have cosine of x. Cosine goes between -1 and 1. But if you're multiplying by 0, that's really not doing anything. So it's like, -1 to 1 times 0, which is 0. So it's 0 minus 1 over 2e. E times -1 is -e. Over 2e is -1/2. Okay, so the limit is -1/2. What does that mean? Well, there's going to be a horizontal asymptote at -1/2. Right? Our function is going to be approaching -1/2. And so the horizontal asymptote will be y equals -1/2.